Okay, so today's lesson is going to be a bit more conceptual. We're not actually going to be doing any coding, but instead we're going to be taking a look at all the different parts of an application and how they come together to create the apps that you use every day. So you may have heard the terms like client, server, front end, back end, or full stack before. And today we're going to actually make sure you know what each of these terms mean and how they relate to each other. Okay? So the first thing that we're going to start off by talking about is the client. Um, you can think of the client as the device you are accessing an application on. So for example, when you access the YouTube app on your phone would be the client. Or if you access YouTube from your laptop, from a web browser, then your browser is the client, right? So it's really just the device that you're accessing a website on. The front end refers to code running on the client. So like your phone or computer, it's actually running on your computer. It is primarily responsible for actually displaying an application and its data to the user and handling all sorts of user interactions. So to kind of explain what this actually means, we're going to take a look at an example of an app that we've built in Hack for Impact here. So let's go ahead and pull up ccaht.utk.h4.com. I'm going to pull that up and we'll go ahead and go here. So this is the app that we built for the Community Coalition Against Human Trafficking. Everything you see on this page right here, everything you see is the front end code, is handled by the front end code or the client, right? If I were to go ahead and click on the inventory page right here, if I clicked on this button, then this interaction of me clicking on that button is also going to be handled by the front end code. So I'll go ahead and do that. And you see what it did was it took me to this inventory page. And so that transition from the home page to the inventory page, that's handled on the client, on the front end code, right? This page is also a better example of what I mean by displaying data. So as you can see here, we have a bunch of data. We have a bunch of data in our database, right? And as you can see right here, we're actually displaying it all pretty right? So the client or the front end code is responsible for actually taking that data from our database and displaying it, making it look really nice. Okay. And again, the code running in the client is going to handle any interactions I do in the application. So if I come into the search bar here and type in soap, the client is responsible for handling me typing, knowing what I typed, and then displaying just the results of soap to me. Okay. Okay, so that's the client slash front end, but you may be wondering what technology we use to build it. Does anyone want to take a stab at answering that? Like, what do we use to build out these front end components here? React. Boom. Perfect. Yes, so we use React. So at Hack for Impact, we use React and TypeScript to build out the client and the front end. You might remember from the React lesson that as we built the To-Do app, it was displayed on the page, right? It was actually displaying that information to us on the page. Okay. And then before we move on, I want to note one other important thing, and that is that the front end code is actually on your device, right? So any code that you write that's going to be for the front end is actually going to be transmitted, put on your user's device, right? So that's really important to keep in mind because it means if you put something like a password or anything that's kind of critical or supposed to be secure into your front end code, an attacker could easily pull that from that code because it's on their own device and then do all sorts of crazy stuff. Okay, so you want to keep in mind you don't want to put any passwords or anything sensitive into your front end code. Okay, sweet. So any questions about the client or front end code or anything like that? All right. All right, sweet. So now we've got the code to display our pages to the user, but where does the data actually come from? So as we learned last week, the data itself is stored in a database, okay? And that's great, but one thing we didn't touch on is how we can actually use the data stored in our database in a React application. There are a couple of ways that we could go about solving this problem of using our data from the database in a React application. And the first one that might come to mind is to just directly connect to the database from the front end, which might work, but it does have a major flaw. Does anyone want to guess what that flaw might be, Logan?
It's not secure.
Exactly. Yeah. So it's not secure. So the problem with like just connecting directly to the database from the front end is that we need a URL that specifies which database we are reading from and writing to, which you saw last week when I opened Compass and like had that string where I put it in and connected to a database. We need that string in order to connect to the database. This is essentially a username and password for our database. So if we put that on the front end, then any attacker could come in, rip that from our code, and do whatever they wanted with our database, right? So what we really want to be able to do is we want to run database code in a secure environment, right? And then send the results of that database code to the client. And this is exactly what a server does. So a server can interact with your database in a secure way, and then once it's interacted with the database, it can send the results of those interactions back to the client or like your phone or computer, right? More formally, a server is a computer somewhere that can take in something called a request from a client. Essentially, a request is the client saying, hey, server, give me some data. And then it sends responses back to the client, which is essentially the server saying, okay, client, here is your data. Okay. Importantly, only the application developer can see the code running on the server. So it's totally fine to put your database connection string in your server and have it used in the server, right? So in order to do that, let's go ahead and, in order to better understand these interactions between client and server, let's go ahead and take a look at the example on the CCHT app again. So on the CCHT page here, oh, where's my mouse? There it is. I'm going to go ahead and right click and I'm going to press inspect, this inspect button down here. And that's going to open up something called my dev tools. I'm actually going to zoom in on this so you guys can see it a little bit better. And then I'm going to click on this like little arrow thing to see some more tabs. And I'm going to click on this network tab. This network tab is going to let us see the communication that happens between my computer, the client, and the server that's actually running the more privileged CCHT code. Okay. So I'm going to go ahead and make sure I'm recording up here. So this button is red, so I'm recording. And I'm going to refresh the page. And so looking after I refresh the page, you see a whole bunch of stuff is brought up in here. I just want to really take a look at the first one. Okay. Let's go ahead and examine this one. We see one called inventory. The path is /inventory, and that actually matches up with this up here. So I know that this is like the actual request for this page. Okay. So let me go ahead and click on that one. Let's examine that one a little bit deeper. Okay. So the first thing I want to point out is that we have some fields in here relating to the request being made, right? That request that we talked about earlier. You'll notice we have this request URL field here. And essentially what that is saying that the client wants the server to send back data for this URL, right? It's saying, hey, client, or hey, server, give me back the data for this URL. Okay. Then you'll also see we have a response tab up here. So we have information about the request, but we also have information about the response, and we can see the response with this response tab right here. Okay. So if I go ahead and click on that, you'll see we're actually getting back a bunch of code. So this is actually the front end code that runs on the client, right? So your server is not only going to send back data, it's also going to send back the front end code that actually runs on your computer, right? Any questions about that server and client and how those interactions work? Okay. So next week, we'll actually go over how to build a server using Next.js. This week is more of a conceptual lecture. But for just to quickly recap what the server is doing, step one, the client is going to say, hey, server, give me some data for a URL. Step two, the server is going to receive that request, right? The request, and make sure that it can do that. Make sure it knows, okay, I know how to, for example, here, it's going to make sure it knows how to find the inventory page. And then once it makes sure it can do that, it will send back a response to the client with the data that it was looking for. And then finally, the client can use that data however it needs to. For example, if the server returns some front-end code, the client will run that code. If it just returns some data, the client can use that data, right? Is that making sense to everyone? Okay. Sweet. So in this example, we've only looked at the server sending back front-end code. But as I just mentioned, sometimes rather than return code, we just want data straight from the database. And so to illustrate this working, I'm going to go ahead and go to a new URL. So I'll also open up my network tab here, and I'll go to ccht/API/inventory items. And I'll click on this one. This is the request for this data. So this is actually only going to return data, and you can see that here. It's a whole bunch of stuff. It doesn't really look like it makes sense, but thankfully Chrome has this really nice feature where I can pretty print it. Oh, thank you. So once I pretty print it, you'll see we actually have some data that looks like it makes sense. You may notice that a lot of this data has this _ID field that we talked about last week, okay? So based on that, it looks like when we ask the server for data from this URL right here, it's returning us back data from our database. That's pretty cool. This is a good example of something called an API, okay? An API, or API, stands for Application Programming Interface, but what does that even mean? Essentially, an API defines what actions the client can perform on the server. In this case, when we visit this ccht.utkh4i.com/API/inventory items URL, we're saying, hey, server, let me get all the inventory items in the database. The server understands this, and it's like, you can do that. So it says, okay, here you go. All right. So before we move on, any questions about that? We'll explain APIs a little bit more in depth in a minute, but just want to make sure we're all good right now. Okay. So let me go ahead and pull up this image here. Yeah. Do you want to just do it?
Oh, yeah.
You might have to like download the image. Yeah.
No, I'm on Notion. Get me out of here, man. I just can't think on this thing, sorry. All right, so the next thing we'll cover is why we actually need APIs to communicate with the server. So like, why can't the correct client just talk directly to the server and tell it what to do with the database? So there are a few reasons for this. So to demonstrate, we'll use an analogy. So imagine that you're in a restaurant. There's you who wants the food and the kitchen that makes the food. The kitchen will do whatever it is told. If someone tells the kitchen to make 14,000 steaks, they will do it unquestioningly. So if I were to just walk in the kitchen, I could tell them, say, hey, make me a steak, give me an apple pie, and some raw potatoes, whatever. And they would do it. They would give me a steak without me having to pay for it because I just asked for it. And they would give me the potatoes, even though it's not on their menu. They don't serve them or anything. They have them in the storeroom. But then they don't actually have an apple pie. So the kitchen staff will just kind of start to freak out and things start to catch on fire and it's overall really bad. So question is, how can the restaurant prevent me from getting free food and burning down the restaurant? And so the answer to that is they can put someone in between me and the kitchen that acts as an interface, in this case, a waiter. I ask the waiter for a steak, raw potatoes, and an apple pie. But before going to the kitchen, the waiter tells me that potatoes and apple pie aren't on the menu, and he'll make me pay for the steak. And he also makes sure that the kitchen makes other customers' orders before mine if they ordered before I did. So essentially, the waiter just enforces the rules of the restaurant. It says what the customer can and cannot do. So now that I have to go through the waiter to get my food from the kitchen, I can't really mess up what the kitchen is doing. And then I have another image. God help me. Get better. So in this analogy, the restaurant customer is the client, the kitchen is the server, the food is what is in the database, and the waiter is the API. Similar to how the kitchen will do whatever it is told with the food it has, the server will do anything it's asked with what is in the database. So to prevent this, we put an API in front of the server to define what the client is allowed to ask for. As a client, I could ask the server to give me information about a user that's in the database. But the API could step in and prevent that by telling me, hey, you're not logged in and you don't have permission to view that user information. I could tell the server, hey, make a new user in the database. And the API would probably make sure that I have a phone number, email, and my name before actually putting that user into the database. Side by side.
Doesn't.
Oh,
Excel.
yeah. How do you?
It should work on the left side, but since it's.
Okay. And where's my other tab? Can you pull up the other tab?
Yeah.
Let's put this on.
You want to move it around? I can move it.
Yeah. See, side by side. Where'd the other one go?
Oh,
I guess you gotta minimize that. All right, sorry, you can't really read that too well. Let's see, where was I? So to reiterate, the customer asks the waiter for food. The waiter makes sure the restaurant serves what the customer asks for and then tells the kitchen to make it. The kitchen will use the ingredients they have, give a finished dish to the waiter, and the waiter brings it back to the customer. Similarly, the client could ask the server's API for a specific user from the database. The API will check if the user or if the client is allowed to access that user information and then tell the server to get it from the database and give it back to the client through the API. One last clarification is that the API is still code that is running on the server. It's not some completely separate entity or anything. The waiter is still part of the restaurant. But the thing to note is that all of our client communication with the server is through this API that defines what we can ask for and if I'm allowed to ask for it. And then the server gives that back to the client through the API as well. Any questions about why we need an API, what it is, and how we use it? Back on to you, Zane.
thank you, Andrew, for that wonderful analogy. I think that's really helpful in just kind of understanding how everything comes together. So I appreciate that. Okay, sweet. So now we know, how an API works, how it's important to this whole kind of how where it fits into building web applications. And we know how we can get some data back using an API. But what if in my app here, what if in this app, I needed to create a new inventory item? I can actually still do that in our API. We can still define that as an action I can take in our API. And in order to understand how that works, we're gonna have to take a quick tangent and talk about something called HTTP request methods, okay? So what do I mean by HTTP request methods? Well, if we look at this network tab in our dev tools, we will see that along with the request URL right here, we also have a request method, okay? We send this method to our server to let it know what kind of action we are trying to perform. And to understand what this means, we're going to talk about the 4 most important and most ubiquitous request methods. The first one we'll talk about is called GET. You can see that this is the method we are sending in this API request right here. Right here, you see request method is GET. And this method is essentially saying that I, as the client, want to get some data back from the server, okay? But getting data isn't the only thing I can do, right? Sometimes I want to create some data. I can also tell the server that I want to create some data using a request method called post. So this one is kind of weirdly named, but I like to think of it, how I kind of make sense of what it means in my head is I think of it like when you are creating a tweet, you're like posting a tweet, right? You're making an Instagram post, a new post, right? Whatever. So we're moving over here into this app that Andrew and I are currently working on for Compassion Ministries. And in this app, which is essentially a volunteer management system, I can create new volunteers. So let me go over here. Oop, not doing that. I can actually create a new volunteer. So let me go ahead and try and do that right now by clicking this new volunteer method or button, sorry. And then I get this form, so I'll go ahead and fill that out. Almost doxed myself. If I could type. Okay. And I'm gonna clear out all this other stuff in the network tab here because I want to see what happens when I press the submit button. So let me go ahead and do that. And boom. Oh, okay. I've got a duplicate volunteer phone number or email. I'll go ahead and change this to Max. And I'll change this phone number to 6 just to make sure everything is good. If I submit that now, then we will see this method here. We're hitting this API volunteers path here, so /API/volunteers, and you'll see that the request method is, as expected, post, right? So what I just did is when I did that, I sent a message to the server and I said, hey, I want to create a new volunteer. I want to create, and it knew I wanted to create a new volunteer because I did it at this path with API volunteers. So I posted a message with this request URL and the server's like, yep, I can do that. So it went ahead and did it for me. And then, we did some redirect stuff, but you can see if I refresh this page, this is actually in our database. So it's going to stay, it's going to persist. It's actually in our database. So the server, I hit that API route. I hit that API. The API was like, yep, you can do this. Everything looks good. It sent a message to the server, told it, hey, I want to talk to the database and I want to create a new volunteer. Then that function then talks to the database and says, create a new volunteer. And then it returns that volunteer back, right?
Might be too late, but can you show the actual payload that was sent to the API?
Oh, yeah. Totes, malotes. Let's see here. Maybe. Yeah. So let's go ahead and look at this payload. So you can see I actually sent the data along with the request, and the server could then use that data that I sent in the request in order to make the volunteer in the database, right? You think I need to highlight anything else there? Okay. Sweet. So that's get and post. That lets you create or get and create data respectively. But oh wait, I messed up my last name, right? So I need to actually go ahead and edit that data to correct it. So with our API, we can do this using the put request method. And this method essentially tells the server, I want to put some new data in place of this data that already exists, okay? The key difference between putting data and posting data is that when you put data, you are modifying existing data on the server or in the database. Whereas with post, you are creating new data. Okay. So let's go ahead and update my volunteer here. I'll edit this and I'll change my last name to Miller and I'll submit that. And we'll look at the request again. What's this one? And you can see if we look back here, we have the request URL. We are saying, hey, I want to edit in the API of volunteer, and then I give it the ID of the volunteer I'm trying to edit, and we make the request method put as expected, right? Okay. Finally, maybe I want to delete this volunteer. I actually don't want this volunteer showing up in my system anymore, so I need to delete it. Thankfully, we have this delete request method, and this one's pretty self-explanatory. It's just deleting some data on the server. So let's go ahead and do that in the app and see what happens. Again, I'm going to clear this out and I'll do delete. Click on this one and you'll see again, as expected, we are sending a delete request to our server. Our server is deleting the data from the database and then returning us back to a list page. Caveat here that I should talk about so you don't get confused. You'll see it's still there. We have a soft delete system, so we actually keep the data, but it's deleted in the database is what you need to know, okay? Don't let this fool you.
One more thing to note, you want to take a look at this request URL /API/volunteers/this long string. That kind of looks a bit like an underscore ID. So from the client perspective, it's pretty clear that you are asking the server to delete the volunteer that has this ID in the database. That's exactly what it does.
Yes. So any questions about any of the request methods that we just went over or anything we've talked about so far? All right. Cool. So to bring all this back to APIs, when we create our different actions in our API, we actually use these methods, so that the API knows what the client is trying to do. Okay. In our example, we have all these things we can do with a single volunteer: view the information, create a new one, update an existing one, or delete one. And the HTTP request methods indicate to the API what the client or your device is trying to do. Okay. So finally, just to kind of wrap this all up, I want to talk about databases. The final piece of the puzzle is databases to actually store the data. We showed MongoDB and Mongoose in depth last week, so if you missed that, definitely check out the video. What I want to point out here, though, is that your server is going to talk to the database. So you remember how we had those actions? We had those like server actions in that actions folder, and in there we like created functions that actually interacted with the database. Your server is going to run those actions, and your API is going to call them, right? And I'm sorry, I've used actions. I've kind of overloaded actions, but those functions that interacted with the database, your server runs them, your API calls them. Okay. Okay. So quick recap. Your device that you access an app on is called the client. The code running on your computer or the client is called front-end code. The front-end code is responsible for displaying the application and handling interactions. Again, this is all happening on your computer. A server, however, is a computer running code that takes in requests to do something. It does it, and it sends back a response. The code that runs on the server is called backend code. The client, your computer, talks to the server to get back front-end code that runs on your computer and any data that it needs in order to function properly. Okay. The server defines an API that tells the client all the stuff that it can do. So for example, getting, creating, deleting, updating, that's all happening using the API. The server is also going to talk to a database, which is responsible for storing data so it can be accessed later. All of this stuff together, all this code together, all these pieces is called full stack. So all the code doing all of this is called full stack code. Hack for Impact projects are full stack. They have both front end, back end, and database code. Okay. And that's it. Does anyone have any final questions about anything, how this all relates together, how we kind of use all of these pieces to create applications? Any questions? Yeah, Peyton.
So the word full stack is just anything that has those three things, database, front and backend.
Yeah.
So like, use that word in a sentence, I'm just curious.
So the most common context you'll hear it in is like, I'm a full stack engineer. That means I work on the front end, the back end, and the database.
Alternatively, I could say I'm a front-end engineer. I only work on the visual front-end stuff.
Yeah. We train full stack developers here at Hack for Impact, so you guys will get good at everything. Any other questions? Good question.
That's a great question.
Oh, nice. It'll come up. All my LinkedIn job postings are like full stack. Yeah.
Like a one-man army.
Yeah, right. Definitely.
Full stack means versatile.
How's everyone feeling about this? About what all these pieces are and how they fit together? Okay, that's good. Conceptually making sense. Yeah. Yeah. Okay, so, well, awesome. I'm glad to hear that. Thanks everyone for coming out. Next week, we're actually going to look at how we can use the stuff we've learned so far, like everything we've used so far, and also some new stuff in order to create a full stack application. So that's super exciting. I'll see you guys next week.
At the general body meeting tomorrow at 6
6.
p.m. It's gonna be great.